Hello, welcome again to this YouTube channel. Okay, now we proceed to some other example. Okay, different kind of example about limit. Okay, we proceed with the simplest version of limit. Okay, if you look at my x, okay, all are two. Okay, there is no special case. I just put some number for you to have some idea how to solve this. All right. Okay. Let first start with a constant function. Okay, what if I have a limit y 5 x goes to 2? If you notice over here, my answer is just a straightforward 5. Okay. Maybe you guys have a little bit confused with this. Okay. So I'm going to show you a little bit why we have 5 in a way. Okay. Let's say I have a function y equals to 5. Okay. You know your function is just a constant function. Okay. It's just like this. Okay, that's why graph sometimes can illustrate more easier for you to comprehend compared to the algebraic process. All right, so if this is your function, this is your fx function. Okay, you can straight away can see over here, this is your x equals 2. See, you can straight away get your value over here. Your left hand side, your right hand side also give the similar values. And whatever happen, if let's say your x goes to 3, 4, 5, and so on, doesn't matter. Your value is still a constant. Okay, your y equal to 5. And the same thing for your limit. Okay, your limit 5 now becomes 5 as it is. Okay, the first one is done already. Okay, now we proceed to the next question. Whatever happened if now we have this particular problem? Okay, you can see over here, this is just a quadratic function. And then this is a straightforward value. You know, when you put an algebraic illustration over here, you can just put things as it is. Okay, so basically you will have uh, 12 minus 2 plus 5. Sorry, I didn't have my calculator with me. So your value is just 15. Okay, that one is clear. Okay, now this one is done already. Now we proceed to this one. Okay, this one looks a little bit interesting. Okay, let's see how to do this one first. Okay, I think I need to put a little bit of a perspective over here. If let's say you just simply plug in your valuation, your x equal to 2 over here, so suddenly you will have your limit 2 minus 2 and then 4 minus 4. Okay, it does not make sense, right? So you cannot really get the value out of 0 over 0, isn't it? Okay, it's a little bit tricky. But whatever happened, if let's say you manipulate or you change a little bit of this formulation, instead of just plug in the formulation, you factorize the formulation, the equation at the bottom of it, the denominator. Okay, you know you have x squared minus 4 can also be written in this form, x plus 2, x minus 2. And then suddenly you can see the denominator and the numerator can now be easily cancelled out. And then you are left with only this simple limit. Okay, so this is your simple limit. All right. And then once you put the algebraic into action, you can just simply have uh, a value that is manageable for you to answer. Okay. So in this case, your value for your complicated function now just becomes 1 over 4. Okay, that one is clear. And then what if we have x that goes to infinity? Okay, again, this similar to the third question. If you just simply put infinity over infinity, okay, like this one, by the end of the day, you get infinity over infinity. This one also similar to the situation where you have 0 over 0. It does not give you much to go on. Okay, so how to do this? Okay, this one is a little bit interesting in a way. Okay, what we do, we should find the biggest power of x, in this case x cube. So you just you just put a denominator for each and every point of it with the biggest power that you find, okay, the largest power. So in this case you have something like this. Okay, put all of them together first before you do any modification in the function. All right, so in this case, the next step, now you can just cancel out certain thing that you can. This one I just put like this, easier for you to see. And then this one I just have if 7 over x square. Okay. Okay, and then now what we have is just 4. Okay, minus 5 over x, this one, and then negative 6 over, okay, we don't have much place to move on, but that's okay. All right. Okay, so in this case, you can see over here, if let's say we have a value that is large at the bottom of it, we can assume the equation, the value now becomes 0. Okay, once you have denominator which is very large, the whole value would become very, very infinitesimally small. Okay, so you make full use of that particular idea, meaning that this value will go to 0, this value will go to 0, this value also will go to 0. Okay, and then you are left now with 4. Okay, so I hope you enjoy the video, and I hope you get the whole concept of writing the solution for this kind of things. All right, so uh, uh, all the best for your future undertaking. I'll see you guys in the next video.